Things get a little bit more complicated when we're asked to predict a redox reaction in solution when we are not given an equation. There are several steps that we need to follow in order to predict whether a redox reaction will occur and what the reaction actually is that is occurring. The first thing we want to do is list all entities present, so that includes molecules and ions. We're then going to label all possible oxidizing and reducing agents in the starting mixture. There are a few hints for listing and labeling entities. So aqueous solutions will contain water molecules. Acidic solutions contain hydrogen ions, or H pluses. Basic solutions contain hydroxide ions. Some oxidizing and reducing agents work in combinations. For example, MnO4 always works in combination with H+. And a few of them can act as either oxidizing or reducing agents, such as water, iron 2+, copper+, Sn2+, and Cr2+. Once we have everything labeled, we're going to choose the strongest oxidizing agent present in our mixture and write the equation for its reduction. We're then going to choose the strongest reducing agent present and write its equation for its oxidation. We're going to get these two equations from our table of reactivity. And the way that they're written is reduction half reactions are read from left to right. Oxidation reactions happen from right to left. Any substances not present in the redox table are going to be assumed to be spectator ions. There's no need to label these. And finally, once we have our two equations, we're going to combine the two half reactions in order to create our redox reaction, and then we're going to use the spontaneity rule to predict whether the reaction is going to be spontaneous or not. Here's an example then. We have a solution of potassium permanganate, and that's slowly poured into acidified iron 2 sulfate solution. Does a redox reaction occur? And if it does, what is the reaction equation? All right, in solution then. Okay, so first off it says solution. So solution means we would have water molecules present. This can be either an oxidizing agent or a reducing agent based on those tips we had in the last set of rules. Potassium permanganate is going to break down into its ions in solution. So we've got K+, which could act as an oxidizing agent, and we have permanganate, or MnO4-, which could also act as an oxidizing agent. Acidified means that we have protons in solution. Again, that can act as an oxidizing agent. The last thing, iron sulfate, iron 2 sulfate in solution, is going to give us iron 2+. And like water, that one can act as either oxidizing or a reducing agent. And finally, the sulfate, the SO4 2-, that acts as an oxidizing agent. Now, you don't necessarily need to label all these or know how to label all of these, but what we want to do is locate each of these molecules within our table of reactivity. And that's going to tell you if it's oxidizing or a reducing agent. Let's take a look then and locate these species on our table. K+ is at the top here. It's on the oxidizing agent side, so that acts as an oxidizing agent. Water is present in this reaction here, and it's also present in this reaction here. So in the first reaction up here, it's acting as an oxidizing agent. Down here, acting as a reducing agent. Same with Fe2 plus. In this reaction, it's acting as oxidizing. In this one, a reducing agent. Our H plus is part of this reaction here. Our SO4 2- actually works in conjunction with H plus, acting as an oxidizing agent. Similarly, the permanganate ion does so as well. If we were to look then at our list of oxidizing agents, we've got quite a few here. The strongest oxidizing agent is going to be down on this side of the table. So our strongest oxidizing agent is MnO4- plus the 8H plus. Our strongest reducing agent is the one that's closest to the top corner of the page. So because we've only got a choice of 2, our iron 2 plus is our strongest reducing agent. So that's the one that's going to undergo oxidation. To get the reaction, we need to write out our 2 half reactions. The first one being the permanganate is our oxidizing agent, so this is the one that is being reduced. So Mn2 plus 4 water. Our second reaction is for the iron 2 plus, and that is our oxidation. Okay, this then just becomes a matter of our balancing. So we're going to add in 5, 5, and 5 here so that the electrons cancel when we add them together, giving us MnO4- plus 8H plus 5 Fe2 plus reacts to give Mn2 plus 4 water and 5 Fe3 plus. In our table, our oxidizing agent was below our reducing agent, so this is a spontaneous reaction.